Here we go, guys. This is the warm-up for our day 3 of volume, where we have a few questions in here that might challenge you. I highly recommend you try to do them beforehand. But let's get going here. The first one is we have a cloth carrying tote that has a square base. I do want to point out, because this happens on our review as well, is that this is a square prism, guys. The carrying case is a square prism. Square prisms do not have to be cubes. Now, cubes are a type of square prism, but if you have a square base and you're a prism, then you're also called a square prism. Just means that the base is a square. Okay, so this is a square prism. It has those dimensions. So right off the top, I can get the volume of the carrying case. So I'm going to do the prism. That volume is 10 squared times 42. That's the area of the base times the height. So that volume is going to be 4,200. Keep reading. We have these cylinder-shaped wrapping paper that we're going to put into the bag. The cylinders have a height of 40 inches and a circumference of 11 over 10. So if we're talking about the cylinders, we know that the diameter is 11 over 10. We've talked about this a lot, but this formula is diameter times pi. This coefficient is the diameter. That means that the radius is going to be 11 over 20. How do I know that? Well, what is 11 over 10 divided by 2? And I've told you guys, don't make your pre-cal teachers tell you this a million times. How do you divide? Well, if you have trouble dividing, think of it as multiplying by the reciprocal. It's the same thing, and that's where we get 11 tenths times 1/2, where the radius is 11 over 20. So the volume of one of them would be pi times the radius squared times the height, which they told us is 40. The height of the cylinders is 40. So let's see what that would be. That would be 11 over 20 squared times 40. That is 121 over 10 pi. That's the volume of one wrapping paper. Now, an issue here is you have to know how many physically would fit. There's going to be empty space, right? Like if you have circles and you put them together and you put them together, there's going to be gaps that aren't going to fill up. Also, the bag has a height of 42, so it's not even making it all the way to the end. So you cannot just do the total volume and divide it by the volume of the cylinder. We cannot just divide those two numbers. These wrapping paper cylinders are not going to fill up this entire case. But what will happen is they're going to have to be stacked somehow. So if we stack them, circle on top of circle on top of circle, how many could we fit in a 10-inch zone? So what we actually need to do is 10 inches divided by how tall is each circle? 11 over 10. So we're going to do times 10 over 11. That would be 100 over 11. When you divide, you multiply by the reciprocal. So this is going to be a little bit more than 9 point something, just barely more than 9. So how many could I physically fit? I could fit 9, and it's the same thing lengthwise. I could fit 9, so there's 81 of them in there. So we need to multiply this volume times 81, and we get 9801 over 10 pi. So how do we get the percent that is filled up? Well, it would be the wrapping paper divided by the prism divided by the bag times 100. So if I type that in, our answer, if let's say we round to the nearest whole number, but it would be 73%. It's a little bit more than 73%. Woo! Fun question. A student has small wax sculptures that have a volume of 1,400 centimeters each. He wants to melt the sculptures and put the liquid wax into a rectangular prism. The prism has this, blah, blah, blah. All right, this is a question that a lot of people do the wrong thing. They try to take this number and turn it into meters, but there's a big issue with that. Almost nobody does it right. They just go 1,400 and they divide by 100 and they say it's 14. Nope, 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 nope. You actually have to divide by 1,000,000. because this is 1 meter cubed would equal 1,000,000 centimeters cubed. Why? Because you would have to cube the ratio, and almost nobody remembers to do that. So I recommend you take the numbers that are not cubed and modify them. So 2/5 multiply it by 100 is going to be 40. 1/50 times 100 is going to be 2. And 91 over 100 times 100 is going to be 91. So the prism is going to be 40 times 2 times 91. That's 80 times 91. That's 720 plus, no, 7,200 plus 80 be 7,280. So 7,280 is the volume of the prism. And each sculpture is 1,400. So it'll be 7,280 divided by 1,400. And that's going to be 5.2. But it says before it overflows. So we can only fit 5 in there before it overflows. So that would be our answer there. So make sure you're converting correctly. Remember, I pay attention to units all the time. Sorry, let me rephrase. I do pay attention to them, but I don't worry about them unless they matter. So please, I don't care about units, but I do pay attention to units. This question, they mattered. Real quick side question. What if instead of before it overflows, what if it said fill completely? How many would you have to melt down to fill it completely? That would be 6. That would be 6. You would have extra. It's okay to have extra. They didn't say you can't have any extra. There would be some overflow or there'd be extra wax. But if I just change that phrasing slightly, now the answer is 6. So you have to understand what the goal of the question is. And the goal here was to not have any extra, to not overflow. All right, graphing, please pause and try to do this. People are still struggling mightily on the graphs. I'm going to get these in here, but please give it your best shot without me. So we're going to be at +7. We're going to go down 2 over 3, down 2 over 3. And we have a domain basically here of 0 to 6. So I started my graph at 0, and I'm going to stop it at 6. Here at 7, the next equation is 2/3 x minus 7. So I'll start at -7, up 2 over 3, up 2 over 3. So here's the other equation. And we know it starts at 0 and ends at 6 on the domain. This is the shape. We're rotating around the line y equals 0. The line y equals 0 is this. That's the x-axis. So we're spinning around the pink line. So as we spin, we connect opposite vertices. Opposite vertices. And what do we get? Let me erase these solid lines. We get a frustum. What are the parts of the frustum? Well, we have a big radius of 7. So big R is 7. We have a little radius of 3. And the distance between the bases, the height, is 6. So every frustum question is the same story. It's a right triangle with a bar. We make big radius 7, little radius 3, height 6, and we need this height. Good practice on proportions. We're going to do x over 3, that's left over bottom, equals big left over big bottom. That's the proportion. Cross multiply, we would have 7x equals 3x plus 18. So 4x equals 18, x equals 4.5. So now we're going to do the volume. So the volume of a cone is 1/3 pi r squared h. And we're going to do big cone. So the big cone is the big height and the big radius spun around. Right? If we're over here, it would look something like this. If you kept going, there'd be a cone here. Right? So we're doing the big cone, and we're subtracting this small cone off. So it's going to be 1/3 pi times big radius, 7 squared times big height, 10.5, minus 1/3 pi times little radius, 3, squared times little height, 4.5. I'm going to type that in. That would be 1/3 times 49 times 10.5 minus 1/3 times 9 times 4.5, and I get 158 pi. That's the exact answer. If I round it times pi, that would be 496.372. And that is the approximate answer. Perfect. All right, the volume of a cylinder, well, that formula is pi r squared h. So we know that 500 pi equals pi times r squared, and they tell us that h is 125 over 9. This is a big skill, Algebra 2 skill. You have to know how to get any letter by itself, right? What are the order of operations? PEMDAS. That's how you go forward, but we're going to go backwards. So we look for this. There's none of that. We look for multiplication and division. We have some of that. Then exponents. Then we go into the parentheses. So if I'm looking at this, look at r squared. What's happening to r squared? If I were to rewrite it, r squared, we have times pi, we have times 125, and we have divided by 9. That's what those numbers are doing to the r. So if I start with 500 pi over here, I need to get rid of pi first. Divide by pi. Pi's gone. And they would actually just cancel out over there. How do I get rid of times 125? Well, I put a 125 in the denominator. I divide by 125. How do I get rid of divided by 9? I do times 9. And then how do I get rid of the r squared? I do a square root. What if it was r cubed? Well, then I would do a cube root. If it was r to the fourth, I would do a fourth root, but it's r squared, so I'm doing a square root. And so this is going to be the square root of 36, which is 6. That's my radius. The next question uses the same idea. It's 1/3 pi r squared h. They said it's the exact same volume, and it's the exact same radius. And now we're solving for h. Same idea. Let's look at h. What is happening to h? We have times pi. We have times 36, right? That's 36. And then we have divided by 3. That's the same as divided by 3. So what do we do? If we have 500 pi, we need to divide by pi. That would cancel out. We need to divide by 36. And we need to multiply by 3. And that's our answer, and that's going to reduce to 125 over 3. That would be the height. One thing you could have realized, this is a high-level thought. See if you understand this. If you have a cylinder and you have a cone that have the exact same base, right? The radius is the same, and they're the exact same volume. So the volume is equal. The cone would have to be 3 times taller to make that work because it is 1/3 the height. So the height, and if it's going to be the same answer, the height would have to be 3 times as much. So could I have taken this height and done times 3? Yep, it'd be the same answer. That's that works very specific cases, but that would have worked here. All right. I really want you to try to do this one by yourself. We've talked about this a lot, so hit pause and try to solve this question. But what is the volume of the figure if the base is a square? We have to know this. This is the height. They gave us the slant height. We have to understand that's connected by the apothem. Because it's a square, the apothem is pretty easy to get. But that's not always the case. We know that the apothem is just half of 48. It's going to be 24. We know that. So the height is going to be 7. So we know that the height of the pyramid is 7 on this problem. But that is not going to be every shape. If it was a pentagon or something, you'd have to get the apothem and do Pythagorean theorem. But this is a 7, 24, 25. All right, so now we know the height of the pyramid. What is the area of the bases? Well, the bases are 48 by 48, so they are 48 squared. So capital B is 48 squared. That's 2304. So we're going to break this down. We have the prism, which is capital BH. So that is 2304 times the height. Well, its height is 18. So 2304 times 18 is 41472. And then the pyramid is 1/3 area of the base times the height. Its base is the same shape. So that's 1/3 times 2304. And we just said its height is 7. So that is 2304 times 7 divided by 3. That's 5376. And the volume of the whole thing is the combination. And that would be 46848. So there's your overall volume. One quick note for you guys, just so you know this happens, this is the other option. What if instead of the slant height being 25, what if this was 25? I still need the height. What connects the lateral edge to the height? This is a radius. So then you have to do Pythagorean theorem with the radius. Let's look at that real quick because people mess this up all the time. If I draw that square base, it is 48 by 48. That means that the diagonal is 48 root 2. That means that the radius here is 24 root 2. So if I take that little sidebar, if I draw that triangle out, if we have 25 and 24 root 2, that'd be the square root of 25 squared minus parentheses 24 root 2 squared. The number one wrong thing I see, and I see people do this all throughout high school. Please stop now. I've seen dozens of people do this in class, is they write it like this and wonder why they're wrong. Order of operations, you're going to square root 2 first, then multiply the 24. That's not what you want. You want to square 24 root 2. That's a very different thing. So this is 25 squared minus parentheses 24 root 2 squared, or it will be wrong. That's what it would look like. This actually couldn't happen because 24 root 2 is bigger. So this was not a great example. This actually couldn't work. But just so you know, you have to put that in parentheses. That was the main idea. All right, guys. Catch you next time. Love y'all.